Good evening, my name is Luisa Mendoza. Again, welcome to my home. This is my report on a mathematician, and for this report I chose Muhammad bin Musa Al-Khwarizmi Abu al-Radiyat. He was a mathematician. He was born on the year 700, around the year 778, and he died around 850 during the Middle Ages, or what is also known the Islamic Golden Age. He was born near the Oxus River in Al-Khwarizmi, we understand that by his name, a province in Central Asia of what is now known as Uzbekistan. As a young man, him and his family moved to Baghdad, the capital of the Arabic Empire, where he worked as a mathematician, astronomer, geologist, and author at the House of Wisdom, which was the center of knowledge and science in Baghdad. Al-Khwarizmi was well versed in the knowledge of the Greeks, the Persians, the Hindus, and the Chinese. Al-Kitab Al-Muqtasar fi Hisab Al-Jabr wal-Muqabala is the book he wrote, which translated is the compendious book on calculation by completion and balancing, which established algebra as a mathematical discipline that is independent of geometry and arithmetic. The book covers the foundational text in text of modern algebra. He wrote the explanation of how to use or how useful is algebra in everyday life in the following words. What is easiest and most useful in arithmetic, such as men constantly require in cases of inheritance, legacies, partitions, lawsuits, and trade, and in all their dealings with one another, or where the measuring of lands, digging of canals, geometrical computations, and other objects of various sorts and kinds are concerned. His contributions to the world, there are so many. He helped draw the second world of the map as it was known in those times. But since the topic is mathematics, one of his greatest contributions to the world are what we know now as the Hindu-Arabic numbers, which is a decimal system created by him using simple arithmetic. He defined a number system, which I would like to explain, as a number theory where the numbers are written as numerical ideograms that with time and use of the cursive writing give us the Hindu-Arabic numbers that we use nowadays. I would like to start by explaining the numbers 1, 2, 4. So number 1 is expressed in this way because it only has one angle. And it hasn't changed much. I mean, nowadays we write it like that, we write it like this, we write it like that. But basically that's number 1. Number 2 is represented by 2 angles. So that's the first angle, that's the second angle. And because of cursive writing, it has been modified and the lines have become smooth, and that's how we know number 2, which sometimes is written like this or like this. Slight variations still number 2. Number 3 was represented, I should say, 3 angles. So this is angle number 1, angle number 2, and the third angle. And again, because of cursive writing, we have this variation, which sometimes is written like this, or written, with different slight variations, but basically the same number again. Number 4 is the expression of 4 angles. 1, 2, 3, and 4 angles. And again, because of the cursive writing, we have it like this. There are people that write number 4 this way, even this other way, but again, it's slight variations, and we understand them to be number 4. The theory for the numbers 5 to 0 is based on the abacus. The numbers at the bottom are represented by 5, and the numbers on top are what represent 10. Because we have 5 fingers, it's just a theory that because we have 5 fingers in one hand plus the other 5 fingers on the other hand, so that's how we represent the numbers at the bottom as 5 and the numbers on top as tens. So basically we see the lines that represent the abacus, the middle line or the middle bar, and the top line, which are represented in these lines and will help us understand the numbers 5 to 10. So the number 10 was the number 5 was basically the bead represented by a circle, and to make the connection with the bar, there was this extension made, and that's how we have, because of cursive writing, we have it represented this way. There are slight variations. Number 6 was represented again by the same bead with what is called an additive angle, which is this, and the number 6 hasn't really changed as we know it. And the number 7, we start again with the same bead and 2 additive angles, which were also changed to represent this way, one angle here, the other angle here, and again because of cursive writing they end up being smoothed out to what we now have, number 7, which is sometimes represented like this and even like that. With slight variations, we still understand it as the same number. Now, the next set of numbers, I'm going to start backwards. So I'm just going to add a line here. And I'm going to start by the number 10, which was represented by the bead on top. And we only added number 1, or we can write number 1 this way. And so that's basically our number 10. Number 9, and again we're talking about the top of the abacus. So number 9 is again the bead, but instead of an additive angle, we call it a diminutive angle. And basically the 9 hasn't changed much. Sometimes we write it like that, but that's basically it. Number 8 starts again with the same bead on the top, and this time with 2 diminutive angles. And because of cursive, we kind of smoothed out those lines, and that's how we end up having our number 8, which is also represented this way, or sometimes we even start on top, and that's how we write our number 8. So that's basically the theory for how we have our numbers based on the Hindu Arabic numbers, or the numerical ideograms. His second greatest contribution to mathematics is what we know as algebra, which comes from the Arabic word Algebra, which means the reunion of broken parts, or simply put, restoration. Algebra is not simply a technique for finding numbers. Algebra has helped create the science of our modern world. There are great contributions, as I said, from Al-Khwarizmi, and as for mathematics and algebra is concerned, we have what we call the quadratic equations. And the way Al-Khwarizmi would solve a quadratic equation is using squares. That's where we use the word quadratic, because it comes from squares. let's say, for example, we have the expression, the algebraic expression x squared plus 4x, and we don't know the next term, which would be our constant. Now, in the expression x2, x, we don't know. We don't know what it is. So we're just going to draw a square of equal sides, and each side will be represented by x. So x times x, and that's how we have our x squared. The next term, or our coefficient, is expressed by 4x. In this case, we understand that we only know one side. So this expression will be, let's say, 4 tiles. And to complete our square, what we're going to do is we're going to divide it by 2, because we're going to add them at each side of the square in order to complete our square. So that's 1. We know this side is 1, and this side remains x. And we are going to add the second tile, and again we know that this side is 1 and this side is x. We're going to do the same thing on this other side. We're going to add a square and another square. So we know that these two sides are 2. So this side would be our 2, and that remains our x. So adding these 2 plus 2, that's how we have our 4x. To complete this square, we still have the mystery. We don't know that number. We're going to complete the square by drawing smaller squares. We know that this side is 1, and we know that this side is also 1. So we have 4 squares to add to our expression, algebraic expression, and we know this is 2. We know this is 2, and this remains x. So this expression could be also written as x plus 2, because it's x plus 2, times x plus 2, which will give us x plus 2 squared. And that's how we have the expression squared. Now, as I said, we have solved the expression. I mean, we have found our expression. 2 times 2. So 2 times 2 we have, or I should just put 2 times 2, is 4. So we know that this number right here is a 4. And to complete this expression as a quadratic equation, we will say that the algebraic expression is equal to x, this expression right here, x plus 2 squared. So that's how we completed our square. We found the number that we didn't know, and we find this complete expression squared. And that's how that's the great contribution that we have from Al-Khwarizmi. And as I said, this is the way he would have done it, but of course now we solve or we find our numbers in different ways. And just to conclude my presentation, I would just like to say that Al-Khwarizmi, he was Muslim, and we understand that the Quran says, or the Quran asserted the imperative of knowledge, and according to the Quran, learning is nothing less than a requirement of God. And that's the end of my presentation, and I hope you have enjoyed it. I really enjoyed doing this assignment, and thank you so much. Bonito los cariños. ¿Qué ha pasado? ¿No está parando?
No está parando.